In this problem, we'll be looking at BVD 4th edition, page 409, number 39. This is from chapter 15. Pause the video at this time and read this problem a couple times. A part says, suppose your school has a mean ACT score of 29. What would its equivalent SAT score be? Key phrase here, means behave like we think they would. Means and expected values behave like we think they would. If it says multiply, we multiply. If it says add, we add. If it says multiply, then add, we do that. So the formula says that the SAT score will equal 40 times your ACT plus 150. So to find that new mean, to find our mean SAT, we're simply going to substitute the ACT that we have. So our mean SAT is going to equal 40 times our mean ACT plus 150. Means behave exactly like we think they should. And it says our mean ACT is 29. 40 times 29 plus 150. $1,310. That's our mean SAT score. All right. B, if your school has a standard deviation, this is A part. This is A. B. If your school has a standard deviation of 5 ACT points, what is its equivalent standard deviation of SAT score? Okay, standard deviation, well, it's a little trickier, all right? We know when we add, it's not going to affect the spread. It just changes where the set is. But when we multiply, it is. So our new standard deviation is just going to be changed by this multiplier. So the standard deviation of our SAT score is going to simply be equal to 40 times our old standard deviation, the standard deviation of the ACT. Standard deviation, a little trickier to figure out how oftentimes we have to use the variance. Okay, we saw that recently. But when we have a multiplier, we can simply multiply our old standard deviation times that multiplier. So in this case, it's 40 times 5 was our previous, and that is 200. The standard deviation of our SAT scores are going to be 200. 40-point spread, a 5-point spread on the ACT is the same as a 200-point spread on the SAT.